Okay, what we're going to do right now is we're going to start, we're going to write some word problems, application problems. And we're going to use problems that will use standard form. Standard form is this form right here. Ax plus by equals c. So that's standard form of a linear equation. We've been working with slope-intercept form, which is like this. We've done word problems with slope-intercept form, and the difference between what we will be doing here and with standard form is mainly just the type of problem. So in standard form, we have a slope, and our slope is a rate. Okay. And when we have standard form, we can use this when we actually have more than one rate, when we have two rates. And so now before we do that, just a quick review of what a rate is. So basically, a rate is just two quantities that change in relation to each other. Okay, so when one changes, the other one also changes. So we have different types of rates that are common. Speed or velocity is one common rate. So for instance, if we have 60 miles per hour, okay, if we have 1 hour, okay, then you would travel 60 miles. Okay, 2 hours of traveling in a car or whatever, that would be 120 miles. Okay, another type of rate is price. Okay, it might be something might be $3. One item might be $3 per unit, or like for a pair of socks. Okay, or each. Okay, I'm going to buy some expensive apples, $3 for each apple. So if you buy one, apple, it costs $3. 2 apples cost $6, etc. Okay, so that's what a rate is. It's when one changes with respect to the other. Make sure you remember that some key words apply. Whenever you see the word per, okay, that's a good indicator that it's referring to a rate. Per just means the same exact thing as for each. So sometimes it'll say per, sometimes it'll say for each, and sometimes it won't say either one, but it will imply it. You'll know what it's talking about. So for instance, if we say something costs $70 for a charger, or like a battery pack. Okay, so $70 for a charger, without me having to tell you that we're talking about one of these. So if you buy two battery, these are nice battery packs. So if you buy two batteries, then it would cost you 70 times 2, 140. One battery pack would be $70, and so on. So what we're talking about there. So we're gonna work on this one right here, and if you didn't know which one you're going to be working with before, you would be thinking, well, how many rates are there? 2 rates or 1 rate? If there's 1 rate, we're going to use slope-intercept form, and we're going to plug it into that. If there's 2 rates, we're going to be using standard form, and we'll use this to plug it in. Okay, so the first thing you want to do is read the whole equation. You should just get in the habit of reading the whole equation one time through. The first time that you read it, you shouldn't really be worrying too much about identifying specifics for the problem. You should just be trying to get an idea of what's going on. familiarizing yourself. So a problem like this should take you maybe 10 seconds to read it. And then you go through and you read it a second time. The second time you're trying to figure out specifics and how you're going to set up the equation. So Joseph is organizing a trip to Disneyland for a group of people. The group will include children and adults. A child's ticket costs $25 and an adult ticket costs $40. Let C equals the number of child tickets and A equals the number of adult tickets needed. If they have a total of $750 to spend, write an equation that models the situation. So I read it once. Now I'm going to go through and just kind of read it a little more carefully. I'll sort through things, decide what's important and what's not important. So Joseph is organizing a trip to Disneyland for a group of people. Okay, that's general information. It tells you a little bit about what's going on, but it's not important for actually setting up the equation. Okay, and same thing with the group will include children and adults. Okay, so we know that. Okay, that's nice. Now this is where it starts to get more specific. A child's ticket costs $25. Okay, I'm just going to go ahead and underline that, or I'll highlight it. Okay, that's something that I can look at and come back to in a little bit. I know this is going to be important. This is telling me some specific information about the problem. Okay, and then the next thing that falls in that category is the second half of that sentence, compound sentence, right? So that's one phrase, and it says an adult ticket costs $40. So I'm going to underline that. Okay. Let C equal the number of child tickets. Okay. We have a variable, and then it describes the variable, so it's equal. And then same thing over here. We have another variable, and it describes the variable. And then they have a total of $750 to spend. Okay. Now, so I'm going to go ahead and highlight the things that have numbers for now, and then just leave, and then we'll come back and do the variables and figure that out later. Okay, so we can see right away that's going to be a variable. That's a variable. Okay, so let's go ahead and figure out how this all works. Now, if you look at the structure of the equation that we're using, okay, this is going to be a total. Now, the A, okay, this is a constant, but this will be basically our rate, okay, the numerical value for the rate. Now, this is actually part of the rate also. This whole thing is like a rate term. But this is the variable. So I'm going to call this a rate variable. Okay, so that's our rate. That'll be like the number, and then this will be the variable that goes with it to make the whole thing. Now, this right here, well, it's the same thing. We have a rate and a rate variable. Now, we want to be able to keep track of these when we're, doing this. So I'm just going to call that rate 1 and rate 1 here. So rate 1 and rate 1 variable. Rate 1, rate 1 variable. So this would be like our A, that's our X up here. And then down here we have rate 2 and rate 2 variable. That would be B, that's Y, the constant. Now notice that's all by itself over here. So when you add all of these, you combine, you multiply, and then add, you calculate this whole side, you evaluate it. What you have left is the total. So that's our constant, which is the total. And that's going to be C, right? Now the way that's different here is that we combine all of these. The total on this one is actually the Y. So we have a constant, we have a variable total. Here we have a constant total. Okay, so anyway, back to this. So we're looking for, the first thing we're looking for is, do we have one rate or two rates? If we have one rate, we're going to use this. If we have two rates, it'll be this equation. So you can kind of keep in mind that a price, anytime you see a price, that's a rate. But also remember it's for each or for every, for a, per. So if you can put that a phrase like, for each or per, if you can put it into the phrase or the sentence without changing the meaning, then that's a rate. Okay, so it says a child's ticket costs $25. Okay, well, you could also say that by saying a child's ticket costs $25 for each ticket, right? So each child's ticket costs for each child's ticket it costs $25 or $25 per ticket, and it means the same exact thing. The same thing with the adult ticket. It cost is a price, right? I mean, the price is $40, right? So price, that's going to be a rate. It's $40 for each one. Okay, so $40 $25 for each child's ticket, $40 for each adult ticket. We could also use the word per. So those are going to be variables. I mean, not variables. Those are going to be the rates. So child ticket, the rate is $25. Okay, $25 per ticket, right? To be more specific. And then the adult ticket is $40. Again, per ticket to be more specific. Now we want to figure out how the variables are going to fit in. Okay, so because the variables go with the rates, right? So you see child's ticket. Okay, this is rate 1. Okay. Now we want to look at the variables and we say, see, one variable is the number of child tickets and the other one variable is the number of adult tickets. Well, we're going to go with C being rate 1. So that one goes with the child ticket. C is that one. Put C in there. The adult tickets, that goes with the number of adult tickets needed. Okay, that's going to be A. And then finally, they have a total. Okay, now sometimes the word total won't be in the phrase. If it is there, then it makes it easy. You can just go down here and say, okay, well, total, and then double check to make sure that that total is actually a constant. So if it was a variable like like y, for instance, then it would be something different. But as long as it's a constant, remember a constant is just a number that doesn't change, right? So 750 doesn't change, it never will. It's just 750, so that's our constant. Once you've identified all of the different parts, then you just plug it in. So you end up with 25a plus b. So the second variable is a. Oh, I made a mistake, didn't I? It's 25c plus 40a equals 750. And that's how you write the equation.